Benchmark 8249. Use the relationship between square roots and squares of a number to solve problems. Number 1, Part A. What are the solutions to the equation n squared equals 100? When you're solving an equation with an exponent of 2, you need to think about inverse operations. Remember that adding and subtracting are inverse operations, which means that one operation reverses the other one. Multiplying and dividing are inverses, and squaring and the square root are inverses of each other. So in order to solve this equation n squared equals 100, we need to know what n is, not what n squared is. So to get rid of that exponent 2, I need to take the square root on each side. The square root of n squared is n, and the square root of 100 is 10 or negative 10. Remember that there are technically 2 square roots. The positive square root is sometimes called the principal square root, and then the negative square root. 10 squared equals 100, and negative 10 squared also equals 100. Remember, a negative times a negative is a positive. Part B. An equation has negative 4 and 4 as its solution. What is the equation? Well, negative 4 and positive 4, if you follow what we had for our first equation, I'm going to use the same variable then, so n squared equals 16 would be our equation. The square root of 16 is 4 or negative 4. The next benchmark is 8311. Use the Pythagorean theorem to solve problems involving right triangles. So the Pythagorean theorem, on your formula sheet, you will get the Pythagorean theorem. It's a squared plus b squared equals c squared. And remember, the Pythagorean theorem is only for right triangles. It's only for right triangles. A and B are the legs. They're the legs of your right triangle. And C is the hypotenuse, or the longest side in the right triangle. So the legs are the 2 shorter sides, and the hypotenuse is the longest side. So the first question here, Part A, number 1, Part A, the 2 shorter sides of a right triangle are 8 and 10. What is the length of the longest side? Well, the longest side has to be C. So if the shorter sides are 8 and 10, the shorter sides are A and B. So I plug in 8 and 10 for A and B. The order doesn't matter. For the legs, the order doesn't matter. So 8 squared is 64, 10 squared is 100. Because those numbers are on the same side of my equation, I add them together. So 164 equals c squared, and then I take the square root on each side. So c equals the square root of 164, or if your answer choices are rounded to the nearest tenth, the square root of 164 is approximately 12.8 centimeters. So the exact answer is the square root of 164. The estimate is 12.8. Part B, the 2 longer sides. So instead of the 2 shorter sides being 8 and 10, now it's the 2 longer sides of a right triangle are 8 and 10 centimeters. What is the length of the shortest side? So the shortest side, for my picture at least, is A. So A squared plus 8 squared equals 10 squared is our new equation to solve. So this one's a little bit different than the last one. A squared plus 64 equals 100. Now that the 100 and the 64 are on opposite sides of the equation, instead of adding them together, we need to subtract them. So if I subtract 64, I get a squared equals 36, and then I take the square root. the square root of 36 is 6. So A equals 6 centimeters. Our next benchmark is 8312. Determine the distance between 2 points on a horizontal or vertical line in any coordinate system. Use the Pythagorean theorem to find the distance between any 2 points in a coordinate system. So first it's saying that you need to be able to determine the distance between 2 points that are horizontal or vertical. So that means that you could count that distance. And then the Pythagorean theorem, that comes in when your distance is not horizontal or vertical, but diagonal instead. You want to use the Pythagorean theorem to calculate that distance. So point M is located at 3, -1. The length of MN is 5 units. What are the coordinates of N if N lies in quadrant 1? All right, so I'm going to draw a graph over here. And I'm going to plot my point M at 3, -1. So that would be right here, 3, -1. Now, the length of MN has to be 5 units, and N has to lie in quadrant 1. Well, quadrant 1 is here, the positive quadrant. Quadrant 2 is over here, quadrant 3, and then quadrant 4. So if point N has to be in quadrant 1 and 5 units away from point M, I can simply count up 5. 1, 2, 3, 4, 5. So this is where my point N would be. So I can draw my segment, has a length of 5 units, and point N up here would be 3, 4. So that's part A. Part B is much trickier because part B is saying that we need our new point to be in quadrant 2. So to be in quadrant 2, this is much more complicated. If you have graph paper for a problem like this, it's going to be much easier than drawing your own graph. So I would definitely suggest using graph paper. Remember, our goal is to use the Pythagorean theorem to help us out here. So our point M is still at 3, -1. Our point N has to be somewhere in quadrant 2. So remember quadrant 1, 2, 3, and 4. So our point has to be somewhere over here in this quadrant. Not on the axis, but in the quadrant. So no matter where we plot the point, it is going to end up being a diagonal line. It's not going to be something that we can count. It's not going to be horizontal or vertical, because vertically, we already found our point in quadrant 1. Horizontally, that would put us in quadrant number 3 if we went over horizontally. So we need our diagonal distance to be 5. The diagonal distance, hopefully you remember, the diagonal distance, when you're doing the Pythagorean theorem, let me erase my quadrant 1 for a moment. When you're doing the Pythagorean theorem, remember that the diagonal distance is the hypotenuse. So that means that the 5 has to be C. So I want you to remember that 5 squared is 25. So basically we're looking for two numbers that when we square them, they add up to 25. Now we've seen this triangle, this particular special right triangle, this Pythagorean triple. We've seen it before. So the Pythagorean triple that we're looking for is a 3, 4, 5 Pythagorean triple. Because 3 squared is 9 and 4 squared is 16. They add up to 25. So the horizontal and vertical distances that we need to use are 3 and 4. So from my point M, if I count over 1, 2, 3, that's not far enough. So I'm going to have to count over 4, and then I can go up 3. 1, 2, 3. So this is my new point N right here, and I'll show you that this is the correct location by creating my right triangle that goes with my Pythagorean theorem. So on the side right here, this distance would be 3. Then on the bottom, this distance right here would be 4. And then this would be my C. 3 squared plus 4 squared equals C squared. So that would give me 5 for my hypotenuse, which is what I need. If you're not able to remember that 3, 4, 5 is a Pythagorean triple, you're going to have to guess. You're going to have to plot some points in the second quadrant and then use the Pythagorean theorem or the distance formula to calculate the length of your segment from M to N. So it might take you a couple of guesses before you find the correct location. But don't give up. Don't give up. Plot your point where you think it could be for N, draw your segment, create your right triangle, and find that length, okay? And then if you're off, erase it and plot a new point for N and calculate your new distance. The alternative would be to write ordered pairs, and if you write the ordered pairs, then you can do the distance formula with the big square root. So my point for N that is correct is -1, 2. So in quadrant 1, the correct answer is 3, 4. In quadrant 2, the correct answer is -1, 2. And that's the only point in quadrant 2 that's going to give you a distance of 5.